Hello everyone, and welcome to today's chem lesson. Today we are going to talk a little bit about chemicals and how we can differentiate between some of the common terms that get used when we start talking about chemistry in general. We're looking at atoms, molecules, elements, and compounds, and trying to figure out what the differences are between those four words, what the similarities are between those four words, and how they're each different. Right? Now, before we can talk about any vocab, we want to start by defining a chemical. Right? You hear the word chemical thrown around all the time, and in chemistry, we're going to talk a lot about chemicals. A chemical is any substance that has a definite composition. And what that means is that it's the same, exactly the same, every single time you look at it in every single place that you can find it. That means carbon dioxide, which is one carbon and two oxygens together every time, whether it's carbon dioxide here, whether it's carbon dioxide in Canada, whether it's carbon dioxide in Italy, carbon dioxide in Nigeria, carbon dioxide in Japan, right? No matter where you go, carbon dioxide is carbon dioxide, right? It is CO2. Same thing goes for water. You take water, a sample from any place, it is H2O. Right? There's no weird lake somewhere that's H3O. There's no weird lake somewhere that's H1O. Right? All water is H2O. Right? That's a definite composition. It's the same no matter what. It has the same chemical composition no matter where you go, no matter what you look at. Right? So when we talk about elements and compounds, we're taking a closer look at these chemical formulas and trying our best to differentiate them. Right? An element versus compound is going to be differentiated by the number of capital letters in each substance. Carbon dioxide has a capital C and a capital O. Water has a capital H and a capital O. Oxygen has just a capital O. That makes these three things a little different from each other. If I pull up the periodic table of elements right out of our reference table, we can see each and every element that is here. And now I said something about capital letters before, because if you look, no matter what symbol you pick, there is only one capital letter. All right, whether it's just one letter, that's capital. If it's two letters, one of them is capital. If it's three letters, only one of them is capital. Right, there's only one capital letter no matter where you look on the table. Every box which contains an element has one capital letter in it. So if we see something like CO2 with two capital letters, we are immediately clued into the fact that this thing has two elements in it. But Mr. M, who cares? Right? What does it matter? One capital letter, two capital letters, six capital letters. What difference does it make? Right? That difference is going to tell us if we're looking at an element or if we're looking at a compound. All right, let's get some definitions down. An element is a substance that can't be broken down any further without destroying the substance. There are 118 of them. They are all on the periodic table. Right? A single element means a single thing off of the periodic table. When you have multiple elements bonded together, multiple elements combined, you see a compound. And that's where that difference comes in, right? Boron, a single capital letter, is an element. But carbon monoxide with 2 capital letters is a compound. Right? The difference between an element and a compound is how many elements make that substance up. Right? One element, you call it an element. Multiple elements, you call it a compound. Now, there's another set of terms here, though. We have the idea of an atom and a molecule. An atom is talking about a singular building block. Right? An atom is a singular building block. When you have multiple atoms together, right, whether that's the same or they're different, right, a singular building block, a singular piece is an atom. But multiple bonded together makes a molecule. Right? When we look at a chemical formula, we are evaluating 2 different aspects. We are evaluating element versus compound, and we are evaluating atom versus molecule. If I take a look at something like C6H12O6, right, if I take a look at sugar, I'm going to evaluate this thing. Is it an element or is it a compound? But to tell the difference, I'm going to look at the number of capital letters. Right here, I've got a capital C, a capital H, and a capital O. Multiple capital letters means this is a compound. To evaluate whether or not this is an atom or a molecule, I'm going to look at this substance and see how many pieces make it up. I've got 6 carbons, 12 hydrogens, and 6 oxygens. That's a total of 24 different things, 24 different pieces. Any more than one makes it a molecule. Something I'm going to introduce here that's going to come back often. If you see something like this single boron, or this carbon monoxide, and you don't see any numbers here in the subscript spot, you can always assume there is a 1. We're not always going to write it because it starts making things look really messy. But when you're looking at any chemical formula, right, let's say H2O, H2O is the same as H2O1, right? Any non-subscripted number is a 1. So let's take a look at some practice problems. For this carbon dioxide, is it an element or a compound? Right, is this an element or is this a compound? Here, carbon dioxide is a compound. Right? You're calling it correctly in the chat. Multiple capital letters clues you in that this is a compound. What about Ag, silver? Is it an element or is it a compound? Okay, good. Here we have an element. Only one capital letter, right? Capital letter is going to tell us the difference between element versus compound. One capital letter makes an element, multiple capital letters makes a compound. What about this one? Oxygen, O2, an element or a compound? Okay, so here we have a toss-up. Some people are saying element, some people are saying compound. Like I said before, element versus compound is determined by number of capital letters. There is only one capital letter here, which means this is an element. For it to be a compound, it needs two different capital letters. Now, for O2, same substance, is it an atom or a molecule? This is the pluralization that you wanted to do before. You wanted to call this a compound because you saw this 2 here. But the subscript, the numbers, don't have to do with element versus compound. The numbers have to do with atom versus molecule. Here there are 2 O's. 2 O atoms makes a molecule. When we're looking at element versus compound, we're saying how many different capital letters are there. When we're talking about atom versus molecule, we're saying how many things are in this, right? Subscripts, we're counting the subscripts. If it's more than 1, it's a molecule. If it's just 1, it's an atom. What about this question? At this point, we don't know enough to translate these names into chemical formulas, and so I will do it for you. But once I give you those formulas, can you tell me which of these things cannot be decomposed into simpler substances? Wonderful, wonderful, wonderful. We got it in 1. Choice 2 is the correct answer here. when they use this phrasing, what substance cannot be decomposed into simpler substances, what they're asking is which substance is an element. Now, you can't break elements down into something simpler, but these compounds, right, 1, 3, and 4, can all be simplified. You can break them down into the pieces that make them. Can't do that with aluminum. Can't break it down into the pieces that make it. Aluminum, the symbol for aluminum does not have two capitals. It's a capital A and a lowercase l. All right. Be really careful. When there are capital I's, right, this is a lowercase I, this is a capital I. This is a lowercase l, this is a capital L. Right? In chem, you will always see the, head and tail on a capital I. Right? A really, really common mistake is on things like aluminum, things like chlorine. Capital A, lowercase l. Capital C, lowercase l. Capital C, capital I. Right? It's really easy to make that mistake. So from the start, I will always have the caps. Right? The head and the tail here. And with that, actually, we are going to transition ourselves over to our Zoom for questions, comments, concerns, and attendance. And I will see you there.